Good morning, everyone. I am Shalane Claire A. Napinas, and this time I will discuss to you the decomposition forecasting with trends and seasonal components. Actually, this is just a continuation of our last topic discussed by Ma'am Maroliano, the decomposition method. This method is used when you have data with a trend and seasonality altogether. This is the most complex method among the ones that we have learned and covered so far. The decomposition approach to forecasting recognizes that a forecast cannot be completed unless you include all the components of historical data. Although the components may vary depending on what variable you are attempting to forecast. When both trend and seasonal components are present in a time series, the forecasting model selected must address this. The process of isolating linear trend and seasonal factors to develop more accurate forecasts is called decomposition. Nevertheless, these abstract models provide a simple framework that you can use to analyze your data and explore ways to think about and forecast your problem. To develop a forecast using the decomposition method, there are 5 steps to follow, and to further explain, let's proceed to the next slide. So our first step is compute seasonal indices using CMAs, or what we call centered moving averages. In this step, we need to compute seasonal indices for each season. In the decomposition method, the first thing we do is to find out what are those values in getting the CMA to get our seasonal index. I will not go deeper with this step since we already taught in our previous topic about on how to get this. We will use the result of our seasonal index of each quarter, which are 0.85, 0.96, 1.13, and 1.06 for the quarter 1 up to the quarter 4 respectively. And now let's proceed to the second step, to deseasonalize the data by dividing each number by its seasonal index. That is, deseasonalize is equals to sales divided by seasonalized index. In the next slide, so we are able to create deseasonalized sales data in step 2. Remember, in step 1, we already got our seasonal index. These indices are being distributed in every quarter of every year. So in year 1, the quarterly seasonal index are being put here, as well as in year 2 and year 3. So they have the same value in every quarter. After that, we can now divide our sales to the seasonal index to get our deseasonalized sales. So in here, the sales of 108 is being divided to seasonal index of 0.85, and you will get the 127.198. This will be our deseasonalized sales for quarter 1 of year 1. In year 1, quarter 2, 125 divided by 9.96, that will gives you 129.859. This same formula will be applied in every quarter of every year. Moving on, step 3 is we need to find the equation of a trend line using the deseasonalized data. The trend equation is y, or what we call predicted value, is equal to b sub 0 plus b sub 1, where b sub 1 is our slope of the line and b sub 0 is our intercept. The value of b sub 0 and b sub 1 are unknown. Therefore, we need to find it first. To get this, find a trend line using the deseasonalized data. So, we let x be the number of quarters and let y be the deseasonalized sales. So, we need to add all the value of x and all the value of y to get the summation of 78 and 1,680.091 respectively. And then, aside from that, we have to multiply our x to our y per quarter. Like this one, 1 times 127.198, that will gives you 127.198. And then for the quarter 2, 2 times 129.859, that will gives you 259.718. The same computation will apply in every quarter, and you have to add all the value of the xy so that you will get the 11,255.702. And again, we have to also to solve the x squared. So we just have to square the x of 1, that is 1, squared of 2 is 4, and squared of 3 is 9. The same formula again to be applied in getting this x squared, and the same rule, adding this value to get our summation of x squared, that is 650. Now, we will have to find our b sub 1 where our n is 12. And because we have 12 quarters in 3 years. So, b sub 1 is equals to n to be multiplied by our summation of xy minus summation of x to be multiplied to our summation of y all over n to be multiplied to our summation of x squared minus the exponent of 2 of the summation x. So, by using the proper formula, we will put the end, the 12, times the summation of xy, that is 11,255.72 minus the summation of x, that is 78, and then to be multiplied to our summation of y, that is 1,680.091. And that will give you the total of 4,021.329 all over the value of n, that is 12, to be multiplied to our x squared, that is 650, and then minus the exponent of 2 of summation of x, that is 78 times 78, and that will give you the result of 1,716. And then we have to divide the 4,021.329 to 1,716, and our b sub 1 will be 2.34. Since we have the value of b sub 1, and now we can solve our b sub 0. So, summation of y minus b sub 1 to be multiplied to our summation of x all over n. So, the summation of y, that is 1,680.91 minus to our b sub 1, that is 2.34, to be multiplied by our summation x, that is 78, and that will gives you 1,497.303 all over n, that is 12, and we need to divide the 1,497.303 divided by 12, then our b sub 0 will be in 124.78. Next step is to forecast our future periods using the trend line. This equation is used to develop the forecast based on trend. That is, y equals b sub 0 plus b sub 1 to be multiplied by x, where our b sub 0 is equals to 124.78, while at our b sub 1 equals to 2.34, and then x will be our time. The value of b sub 1 and b sub 0 was based on the result on our computation in step 3. Here, we need to find our trend forecast of quarter 1 to quarter 4 of year 4. But if you do the calculations by hand, the numbers may differ slightly from these results due to rounding. Again, our formula is y is equals to b sub 0 plus b sub 1 times x, where our given b sub 0 is 124.78 and our b sub 1 is 2.34. And let our x quarter 1 of year 4 is equals to 13, and then 14, 15, 16 for the quarter 2 to quarter 4 respectively. And now we will have to develop our trend forecast for quarter 1, year 4, where our x is equals to 13. So, applying the formula, b sub 0, 124.78 plus b sub 1, 2.34 times our time period, that is 13, that will gives you 155.24. So in here, this same formula and solutions will be applied to get our trend forecast for quarter 2, 3, and 4. So for quarter 1, 155.24, quarter 2, 157.58, quarter 3, 159.93, and quarter 4 is 162.27. So this will be our trend forecast for quarters of year 4. And then we need to multiply the trend line forecast by the appropriate seasonal index. This is the last step that we need to follow. The result of trend forecast in step 4 is to be multiplied by appropriate seasonal index to make a seasonal adjustment. So our equation will be adjusted forecast is equals to y or trend forecast times our y sub 1 or seasonal index. But again, remember, if you do the calculations by hand, the number may differ slightly from these results due to rounding. So our adjusted forecast is equals to y times I sub 1. So we already have our value for seasonal index, and then we have also the value for our trend forecast. To get our final adjusted forecast, we will need to multiply the trend forecast 155.24 times our seasonal index 0.85, that will gives you 131.81 for quarter 1. And then for the quarter 2, 157.58 times 0.96, that will gives you 151.69. And then for the quarter 3, 180.96, and quarter 4 is 171.54. So this will be our result, and this will gives you a final adjusted forecast of year 4. So that is what we call decomposition method. That will be the end of my report. Thank you for listening.